A bouncing ball can be the source of a lot of intrigue, and not just to the athlete or sports fan, but to the people in the science community as well. We geeks got game too. And we might just play a little bit differently sometimes. And we have better equipment like this Passport motion sensor, because we might know just a little bit more about the potential of a bouncing ball than Joe Jock might. We're going to show you how to use your Xplorer GLX to perform mathematical operations on the position and velocity information we obtain from this sensor so that we can study the gravitational potential energy and the kinetic energy of this bouncing ball. Now, just like in any other game, besides having great equipment, you might need to have some great teammates, and I brought in a ringer. Now, if you have a couple of rods, you'll want to set it up like we have here. If not, you'll probably want to recruit a third team member to hold your motion sensor for you. If you are using the rods, you will want to put them through these holes on the motion sensor and then secure the sensor to them using this thumb screw. Also, you'll notice that there are two settings on the top of your motion sensor. Make sure that you have it set to the long range or people setting. Okay, we're ready to mount this. Go. Now, one thing you'll want to notice as my teammate puts that sensor on the rod is that he is rotating the face of it so that it is pointing toward the ground. Before we connect the sensor, we want to make sure that everybody is starting in the same place. Now, if you just powered on your Xplorer GLX, it will have automatically opened with a new file. But if you didn't, let me show you how to create a new file. We need to go to the data file screen, which is already selected for us up in the top left-hand corner. So we will push the check mark to open it up. You can see here that we can open, save, or delete files, but we're here to create a new file. So push your F4 key or button to open up your files menu, and you see the first item listed there is new file. Push the check mark to select it, and now you have a new file created. So let's go back to the home screen and connect our sensor. It can go to any one of the ports on the top, and you see that when we do connect it, the sensor opens up, or the Xplorer GLX automatically opens up with a graph display of position versus time, which we appreciate very much, but we also would like to see velocity on this graph display. So we're going to create a two graph screen for this display. So go to your graphs menu, F4, and you see item number 5 there, two graphs. Push the 5 to select it. So now that we have two graphs, position versus time and Y versus time. So we need to tell the Xplorer GLX what we want our Y to be, which is position. Hopefully, velocity. Hopefully you remember that to change any of the measurements or units on your axes, you can do that by pushing or turning on your hotspots, which we do by pushing the check mark. To get to the hotspot that you wish to change, use your arrow keys, and then once you have that highlighted or shaded, push the check mark to select it, and you see there are a list of data sources. We don't want position. Let's check out what we have under our more selection, and there it is, velocity, acceleration. Let's push the check mark to select velocity, and now we've got position versus time and velocity versus time, and we are ready to collect data. So I'm going to push the start-stop button, and as soon as I do, or as soon as my teammate hears the clicking of the motion sensor, he will release the ball. Notice, before we start, that he doesn't have the ball any closer than 15 centimeters away from the face of the sensor, which is the lower end of the range of the sensor. Ready? Okay, and then we'll push stop to end data collection. And let me hit the auto scale button so we can take a good look at what we have here. So that information looks pretty good, but I'm willing to bet that many of you are missing some critical information around some very interesting events of the ball's bounce. what we can do to get a more complete description or picture of the ball's motion is to increase the number of data points that we collect. In other words, we need to increase the sample rate of the sensor. To do that, we need to go to the sensor screen. So let's back out by going to the home page and then go to the sensor screen by pushing the F4 button. All of the sensors collect with the sample rate unit of number of samples per second. Let me just show you something in this field really quick. I'll push the check mark to show you that you can actually change that to seconds, minutes, or hours between samples, so that if you're doing an activity like a weather experiment when you only need to get one data point every 10 or 15 minutes, this is where you would change that setting. Let me scroll down using the down arrow to the next field, which is the sample rate. You can see that the sensor is currently collecting data at 10 samples per second. You can push the plus or minus button to increase or decrease that, but we can also press the check mark to open a menu of items that we can select the sample rate from. So let's select item number 6, 50, to pump up the rate as high as it can go. So now we are sampling at 50 data points per second. That ought to give us a really good picture of this bouncing ball. So we'll go back to the graph display, but I want to show you a shortcut for doing that. If you simultaneously push the home key and the left arrow key, we can immediately get back to the graph display, kind of like using the back button in your web browser. So we're back at the graph display, and we are looking at a run that we don't want. So we're going to delete that run. What we need to do is turn on our hotspots again by pushing the check mark. And then we're going to arrow through our fields there, and you see as soon as we get to run 1, we can push the check mark, and under the menu there, we can select item number 3, delete run. And are we sure we want to delete it? Yes. Okay, F1. Okay, so now we have a clean graph display, and we are ready to collect a second run of data at a higher sample rate. Just at the end of the data run, I'm going to ask my teammate to actually push the ball aside so that we can get a measurement of the height of the sensor off the ground. And you'll see why we want to do that in just a moment. So are you ready? Okay. All right, let's take a look and see what we got. Okay, that's not bad looking data, but let me ask you one thing. Can you identify the place on the graph which represents when the ball hits the ground? If you asked your students to identify that spot, where do you think they would point to? My experience tells me that they usually like to pick the bottom part or the trough part of that curve, because they're thinking the ball's falling down, so it hits the ground when it's down. But if you take a look at our setup, we're measuring the position of the ball from the sensor, not the ground. So what we can do is perform a transformation on this data so that we flip the graph so that it's more intuitive. To do a transformation, we need to perform a calculation on our position data. To perform a calculation, we need to go to our calculator. So let's back out of the graph display by going home and then pushing F3 to open up our calculator. Now in the calculator you can do a number of things. You can use it like a regular calculator where you evaluate expressions. You can use it like a graphing calculator where you plot equations, or you can use it to perform operations on sensor data like we're about to do. What we want to do is define a new position of our ball H so that it represents the height of the ball from the ground, not the sensor. So let's start by defining H, and what I need to do to start is turn off number locks. So I push F4 to open my edit screen, push check mark to deselect item number 1, number locks, which is currently on. So now it's off. And now I can type in text. So I will use the multiple press text entry method to type in H and equals Now, we need to know the height of the sensor from the ground, which we have. Let's go back using our little shortcut to go back to the graph. And if we look at where our data cursor is and the coordinates for that point, it is about 1.511 meters from the ground. So let's push home and then the right arrow key to go back to our calculator, and we will say 1.511, that wasn't it, back, 1, pause, 1, minus, and then we want to say the position of the ball, which is our sensor data. To tell the GLX that we are using sensor data, we push F2, or the data button, and select from our list of data sources their position, item number 1. So we'll check that, and then when we are finished with our expression, you push the check mark again to tell the Xplorer GLX that you're done. And our calculation is okay. So let's see what our graph display looks like now, and you can do that very easily by pushing the F3 button to turn on the preview graph. And if we move our cursor up so that it's on the line with our expression, we see now that our picture of our graph looks more like a bouncing ball. So now though, what we really want to do is study the gravitational potential energy and kinetic energy of this ball. So we will create 2 more expressions, one for gravitational potential energy and the other for kinetic. We will push F3 to toggle off the preview graph. And now we need to define gravitational potential energy, or as we will abbreviate it, GPE. So let's move the cursor down to the next line in the calculator and type in G, P, and E equals M, which is the mass of the ball, times G times H. And then we will push the check mark. And when we do, you see that the Xplorer GLX needs us to tell it what M and G are. Notice that it doesn't ask what H is. We've already defined it in the line above. So we predetermined the basketball to be 0.52 kilograms. So I will type that in, 0.52. Check. And gravity will use 9.8. Check. Okay, so now we've defined our gravitational potential energy, so we can go on to kinetic energy, or KE. Okay, equals 0.5 times, and we'll use M again, times V. And notice that there is no button on the keypad that will let us square the velocity. Take a look in the functions menu by pushing the F1 button, and notice here that there are a number of expressions and constants that we can use in our expression. And if you look down on that third row there, the caret 2, which is the standard convention to square our values. So we'll push the check mark to select that one, and now we've got velocity squared. Push the check mark to tell the Xplorer GLX that we are done with that expression, and it comes back and asks us what V is. Again, notice it didn't ask us what M is. We defined it above. V is data, is the velocity that we obtained from the motion sensor. So again, we go to our F2 button, which reveals our data sources, and select velocity, item 2 on that menu. Okay, push the check mark, and on the bottom left corner of the GLX screen it says calculation is okay. So we are done with this. Let's go back to the graph display and take a look at what this looks like in a graph. So we will go home and back. Now, we don't want to lose this data here. We like these graphs, so what we want to do instead is create an entirely new graph page. So we can keep this graph page. Look at your graphs menu, F4, and item 6 there lets you create a new graph page. And we get one of position versus time. What we want to see on our graph page is gravitational potential energy and kinetic energy, so two measurements on the same graph. Go back to our graphs menu where we hopefully remember that item number 3 there lets us see two measurements. And now we're looking at position and velocity, but we know how to change the data sources on our y-axis, and we do that by pushing the check mark to activate our hotspots. Push the check mark again to select one, and take a look at our data sources there. There's all the calculations, all the expressions that we defined in the calculator. So the one we want here is our gravitational potential energy. So we will select it. And let's go to the other side, push the check mark, use the arrow key to move to our other y-axis, check mark, to select that one. And on this axis we want kinetic energy. Select it. And if we scale it, because of the spikes there, it won't auto scale. So if we push F2, that will allow us to manually scale our axes. But notice a couple things. Our graph display is missing some important items that you would expect your students to use when they're creating graphs, and that is the units for your y-axis labels. So let's go back to our hotspots, select the data property for each of those y-axis measurements, and then add the units to it. Push the check mark. Push the check mark again because we want to select gravitational potential energy. And the last item there, whoops, let's go down back to 8. Data properties. We want this to be joules, J. Oops, push the check mark to select it, J. O. U, L, E, and S. F1 for OK. Now I want to show you something here. Take a look at the axes on this. Notice that for the gravitational potential energy, the scale goes from 0 to 8 joules. And for our kinetic energy, our scale goes from 0 to 300 joules. What we want to do is make sure that our units are aligned for both of those axes. One way that you can ensure that is to make sure that you have the same units on both sides of your graph. So let's go to our kinetic energy measurement and change the data properties for that so that it includes the units. We're stuck there. Whoops, we were just there. Push the check mark to select it and select data properties for kinetic energy. And also for this one we will type in joules. I sure hope you're faster at finding the letters on the keyboard than I am. Okay, check mark, and OK. Now you see that the axes are the same. We've got them both going from 0 to 300. Let's scale it by pushing the F2, and we can use the arrow keys to stretch that up just a bit and over a bit. And now we can see by looking at our gravitational potential energy, which starts up, and the kinetic energy, which starts down, that there seems to be some sort of exchange in energy. Well, we have a challenge for you. What would our graph look like if we looked at the sum of gravitational potential energy and kinetic energy? So we've already created a number of expressions using the calculator. we're going to challenge you to go pause the video for a moment and actually see if you can figure that out yourself. When you think you have it done, come back. We'll be waiting for you with the answer. So how'd you do? Here's our results. Do yours look anything like that? To get them, we used this equation. Now, we put this in a new graph page so we can preserve our other pages, and you see that we have some here on our y-axis, and we also included the units. This represents the sum of gravitational potential energy plus kinetic energy. Okay, now after doing all this work, we would like to preserve it, and there are two ways that we can do this. One is by saving our file, and the other is by printing our graphs. So let me show you both of those. Starting with saving, we need to go back to the data files screen. So we'll back out by going to our home screen and then push the check mark because our data file screen is selected already. And now we can save from here. You can see the F2 button. That lets us save it. But first of all, let's give this file a title so we can remember it. Push the check mark so that we can edit it. And I'm just going to call this BB, short for bouncing ball. Also makes typing it in really quick. Okay, and once we've done that, push the check mark to finish our edit, and then finally push the F2 button to save the file. And now it's saved. Okay, let's go back to our graphs menu using our shortcut. And we're going to print this. Now, if you have a compatible HP printer like we happen to have right here, you can connect it to the USB port on the right side of your Xplorer GLX. And then look in your graphs menu yet again, F4. And you see the last numbered menu item on there. Sorry, it's actually 7 and 8. You have two choices. One is print, the other is print all. If you select print, you will get a page that reflects the graph page that you currently have on your screen. If you select print all, it will print one per page, each of the graphs that you have created. So we will go back to our graphs menu and select item number 7. Let me get this out of the way. Print, which will print our sum page, and you can see that it's going to be waiting here for a minute after we push F1 to print. This is going to take a few minutes, so we're going to take a time out while it prints. All right, here is our graph. It's lovely. We've got some of our two energies against time, and it's labeled also with the experiment name. Now, let's take a minute to evaluate it. You can see that the sum of gravitational potential energy and kinetic energy is relatively constant, and as expected, between bounces we see a little bit of loss of energy due to friction. My question to you as we leave is, can you explain what this sudden dip in energy is between each of the bounces?